Hi, good morning everybody, and thank you for being here on this fine Monday morning in Las Vegas. I hope you all had a great Thanksgiving. We're going to go ahead and get started with brief introductions. I'm Binay Ankalaur. I'm with Intel's Artificial Intelligence Products Group, where I run the customer enabling team. With me is Dib. Go ahead, Dib.
Hi, I'm Dib Banerjee from C3. I focus on areas of supply chain, particularly applying AI machine learning techniques to solve supply chain use cases.
Thanks, Dib. So today we are going to go ahead and first run through our legal notice. And the agenda is pretty simple today. We'll start off with the work that we've been doing with Intel or AWS over a decade. We'll talk briefly about what Intel is doing in the area of AI, and then I'll turn it over to Dib to talk about a use case where they worked with a customer together with AWS on Intel infrastructure. Okay. Okay. So Intel has a decade-plus collaboration in hardware and software with AWS from the edge to the cloud. We share many common values with AWS. We want to drive, on the left side, digital transformation. We have a shared customer passion. And we want to really drive this idea of getting the high performance and lowering the costs of your infrastructure. On the other side, on the joint priorities, obviously we are working on AI and ML together, HPC and analytics, and then all the way over to the IoT and edge computing area. And for the cloud, AWS is such an important partner for us that we build customized Intel Xeon scalable performance processors to AWS specifications that aren't available on premise. These special CPUs power EC2 and fully managed services to deliver the best TCO for customers. And this is actually something that we're going to talk about today as part of the use case that Dib will walk through. Okay. So here's the ML stack. Actually, let me go ahead. Okay, sorry. Okay. I'm sure you're all familiar with the AWS machine learning stack. Intel has worked closely with AWS on many parts of the stack. We've jointly optimized the performance on SageMaker for large-scale deployment. We've also worked on the deep learning AMI that's now available for use on the C5 instance. And then we have continuing collaboration on many AI framework optimizations on Intel hardware. Plus, of course, the work we've done with AWS on Lambda and DeepLens and Snowball Edge. So on the right side of the screen, you see AWS DeepLens. This is something that we worked on to really show this training and cloud inference on the edge type of capabilities. We've also recently worked together to optimize TensorFlow on EC2 CPU-only instances, especially the C5 instances powered by the latest Intel Skylake processors, the Intel Scalable Performance Processors. The work was done in close collaboration with the Artificial Intelligence Products Group. That's the group I work in at Intel, and it resulted in more than a 7x improvement on CPU performance on some benchmarks over the stock TensorFlow. We look forward to continuing the collaboration on innovative new technologies to drive AI forward and provide the best experience for customers. Okay. So I often get asked by customers, hey, Intel, you're a hardware company, you're a silicon company, what exactly do you do in AI? Most people know that we build silicon that's used by our hardware partners, but that's about it. But as you all know, AI is much more than the hardware itself. So what we need to do, and what we do, is we provide software tools that enable you to extract the highest performance and capabilities out of the underlying hardware. And then, of course, there needs to be the ecosystem, and that's the community that we work with, and that includes companies like C3 IoT, to take these tools and hardware and apply AI across vertical and horizontal markets. Over the next few slides, I'll just talk about each of these different areas, starting with the hardware first. So, as you can see, we have silicon technologies available all the way from the endpoint to the data center. And again, I get asked by customers, why do we have so many different pieces of silicon? And the answer is simply that customers demand it. AI is being built into more and more products, and we have different pieces of technology for different capabilities that customers are looking for. For instance, at the endpoint, IoT sensors are being used in security, home, retail, industrial, and many verticals. And low power is crucial. And so, for example, for inference applications like drones, we have the Intel Movidius vision processing units. And in these types of situations, you have a technology that can give you inference for less than a watt of power. And then we also have self-driving vehicles, and Intel Mobileye technology is used in there. And then you're also starting to see inference happening on laptops, and this is where our Intel Core processor family can be used. In the edge area, for the most part, the customers are mostly using Xeon CPUs, but there's areas in here as well there, for instance, where they might be dealing with latency-bound workloads, where something like the Aria 10 FPGA is useful. And then you can also have solutions based on Movidius. And then finally, on the data center, this is where most customers today are doing the deep learning inference and training on Xeons and CPUs. And for intensive deep learning environments, this is where we plan to introduce the Intel Neural Network Processor, and that's coming in 2019. Okay. Okay. Sorry, I'm just trying to see. Okay. So we talked about the hardware in the previous slide. In this slide, I wanted to talk about the overall Intel AI portfolio that sits on top of the hardware. So the hardware that I went over in the previous slide is at the very bottom. What we've got on top of that is the various foundation elements, the different libraries and the math kernel libraries and so on. So think of these as the lower level types of primitives that we offer for you to extract that performance from the underlying technology. And then above that, we have libraries. I talked about TensorFlow. This is where we've created an optimized version of TensorFlow that takes advantage of, through these lower level libraries, of the underlying hardware. And above that, we have toolkits that we provide. So OpenVINO is a platform that allows you to, not a platform, it's a toolkit that lets you take a model that's trained on different hardware possibly, or different in the cloud, and then apply it somewhere else, either in a different type of hardware or on something like the edge. The good news is, with companies like C3 and Amazon's platform like SageMaker, a lot of this is hidden from your point of view. So from your perspective, all you see is that it simply just works. And then another request we get is really around solutions, right? How do I build solutions based on all this? And we provide these types of white papers available on builders.intel.com/AI. So feel free to go there and learn more about it. Okay, so in this particular case, it's a build, but I'm just going to go over this very briefly. At the bottom of this is what we call the time to solution. So this is, where you think about an AI use case and you ask yourself, well, can I apply to AI to it, and so on. And so that's the overall, from where you think about where AI can be applied to where you end up, that's the time to solution. But the next part really is around this idea of build, deploying, and scaling. And in this area, what we want to show in this slide is really, it's more than just training or inference. It's really around how do you get your source data, how do you do the development, and then what's your plan and how are you going to scale and deploy the inference. And an example of this is what C3 will cover. And, but the point I want to bring across is if you look specifically at the training part, a lot of people talk about training and say, oh, well, training is very intensive and so on. It's true, but really it's a small part of the overall cycle of building, deploying, and scaling. And this was an example. I'm not going to spend too much time on this, but this was an example of what it takes to, if you're doing something on-prem for this overall type of deployment. Again, fortunately, with platforms like AWS and C3, you don't have to worry about that because it's all done for you on the cloud. Okay, so the last part of our stack, I talked about the hardware, the tools, and finally the community and the ecosystem. So we announced the Intel AI Builders Partner Program in May of this year, and since then we've got over 100, actually the current count is over 160 partners at this point, that range in a number of different domains, all the way from different verticals to different horizontals. And of course, as you see on the low right under AI PaaS, we've got C3 featured there. And this is where we really look to work with our partners to help you, the customers, be able to use Intel technologies. Okay. So here's an example that C3 did recently. And this shows what they've done here is they've migrated a certain workload from the C3 instance on AWS, not to be confused with C3, the company. And what they saw in moving from the C3 to the C5 instance is a performance improvement of 27%. But at the same time, they saw the total cost of ownership go down 41% in moving from the C3 to the C5 instance. I think this is a key point because what it shows you is that as you scale out, so maybe you did the POC on a C3 instance and so on, but as you scale out on C5, you're actually getting better performance and lower cost, total cost, as you're scaling out. So that has, that's great news for customers as they deal with how they scale out. Okay, at this point, I'd like to turn it over to Deb.
So it is this one. Thank you, Binay. Hello, everyone. So in this part of the presentation, I'm going to break it up into three parts. In the first part, I'm going to provide an overview about how we can apply AI machine learning in the area of supply chain. The second part, I'm going to drill into a specific customer case study. And in the third part, I'm going to share with you some results that some performance improvement results like Binay shared with us using the latest generation of Intel processors. So let's start with the first part about an overview of how we can apply AI machine learning to supply chain use cases. So what you see here is a value chain where you have suppliers at one end and then going forward all the way to manufacturers, logistics, distribution, all the way to customers. Now, customers or companies can use C3 platform to build applications tailored to each of the stages in the value chain using the underlying data that might be sitting in multiple disparate source systems today. So some examples of applications, AI, ML-based applications that can be built are supply network optimization, inventory optimization, fast forwarding into demand forecasting, and all the way to aftermarket insights. These are just some examples of use cases or applications that can be built to address specific customer needs and help drive business performance improvement. Now, today we are going to deep dive into one specific application, which is inventory optimization. But let's try to get an understanding of some of the common pain points that practitioners in the supply chain space face on their day-to-day job. For executives, it's very difficult to get a view, a real-time view of the supply chain from an end-to-end standpoint. The reason being the data resides in multiple disparate systems, and it's very costly, and it also takes a lot of time to bring all of that together to provide that real-time view. Next, without the right analytical tools, it's very difficult for executives to contain the inventory costs or optimize the inventory costs, and at the same time meet service levels, which means making sure that the right product is available in the right quantity at the right time at the right location in order to meet customer demand. Next, the analysts typically work with spreadsheets, ton of spreadsheets, and thus their analysis is generally slow. It's unreliable and many times because the data in the spreadsheets are pulled from a source system at some point in time in the past, so they're working off stale data most of the time. And finally, solutions that are developed based on spreadsheets generally can't be scaled across the enterprise for millions of products across, say, hundreds to thousands of locations worldwide, globally. Now let's take a look at how we at C3 address these problems. So C3 inventory optimization is an application that's built on the C3 platform using AI machine learning techniques to help optimize inventory levels. And what that means is reducing inventory costs, yet at the same time making sure you meet service levels, which is making sure your products are available based on customer demand. Now, based on the projects we have done so far, we have seen reduction of inventory levels by as much as 30% or higher, yet at the same time, customers achieving service levels higher than 99%. In addition to that, our machine learning models are able to predict with high levels of accuracy, more than 80% accuracy, in predicting supplier delays, which is a key aspect around managing the uncertainties for that leads to inventory pileup. Right? So what does that mean for a company that has, a very large company that has more than, say, $1 billion in inventory? It means that that company is going to be able to reduce their working capital, which is currently locked up in inventory, by as much as $300 million. In addition to that, there's around $100 million or more of savings that can be achieved in logistics costs, just because you need to now order less materials and fewer materials need to be moved around. So that's a tremendous benefit for a very large enterprise. Now, how are we able to do that, right? Inventory optimization is not a new problem in today's world, but our points of differentiation are around 4 capabilities. First, it's the ability to use AI machine learning algorithms as against standard rule-based systems that are in place. The ability to do optimization in real time as against the current cadence of doing it maybe quarterly or at best monthly at many companies. The ability to scale across millions of products across hundreds to thousands of locations globally. And finally, the ability to ingest new data types such as weather data, data related to supply network congestion, which leads to better prediction about the uncertainties in the future, and thus better optimized or more optimized inventory levels. This slide shows you a quick comparison along those 4 capabilities that I just mentioned. The column on your left shows you how typically the legacy solutions that have been built, maybe most of them built more than a decade ago, how they operate versus the new approach that we have at C3, which is on your right. So when it comes to data integration, the ability to integrate multiple disparate sources or new data types is a big challenge with legacy systems. However, since C3 is built on the C3 inventory optimization is built on the C3 platform, that makes it very easy to ingest new data types. And I mentioned some examples like weather, supply network, congestion, etc. Second, the use of machine learning algorithms as against very simplistic rule-based systems that traditional solutions use. The ability to do this in real time as against doing inventory optimization maybe on a quarterly or at best monthly basis. And finally, the ability to scale, where we use the C3 platform to massively scale across millions of items at thousands of locations globally. So that was the background about applying AI machine learning in the area of supply chain. So next, I'm going to get into more of a specific customer use case or a case study where customers have realized tangible benefits using this application. So this case study is for a very large, discrete manufacturer which has a global presence in hundreds of locations worldwide. And they make complex machines, and each of these machines can have like tens of thousands of individual parts that go into making the machine. Now, there's two kinds of uncertainties that they typically have to deal with. There's uncertainty on the demand side because these machines are very configurable or customizable. So you do not know what the customer demand is going to be for all these options and configurations. And so that's a challenge by itself. Secondly, there's recurrent delay from suppliers. There are many suppliers which are overseas and they get delayed in providing materials that are required for making these complex machines. As a result, there is an ongoing challenge in terms of figuring out what should be the right level of inventory that needs to be maintained for individual parts at each of these manufacturing locations. Now, they tried to solve this problem using some of the existing solutions out there, but none of those solutions were able to do inventory optimization dynamically as well as at scale. So when they approached us, they chose C3 inventory optimization for doing a trial for one product line at one facility where that product line was covering several thousands of parts. Now, as we went through the trial and developed and tuned the optimization algorithm, we were able to basically demonstrate that there was inventory savings opportunity of the tune of 28 to 52%, depending on the service level that they want to operate in. And that translated to somewhere between 100 to 200 millions of economic value for the company. Now, seeing that proof through that trial, they decided to scale that application up across multiple locations, multiple manufacturing facilities globally. Now, let me share with you what a timeline of the trial was, and this is very typical of some of the trials that we do at C3. So the trial can be, trial typically comprises of like 3 phases. In the first phase, it's about data integration, which basically means working very closely with the customer's subject matter experts and understanding the semantics of the data, identifying the data sources that are required and the data types, and loading all of the data from multiple disparate sources into the C3 platform. Now, once that's done, the next phase is about developing and tuning the machine learning algorithm to optimize inventory. And typically, the output of the machine learning algorithm would be something like a recommendation for the user to reduce safety stock for a particular part at a given facility. And then finally, we configured a user interface for end users to just act on the recommendations coming out of the machine learning algorithm. This is a view of the C3 inventory optimization application in the broader context of the C3 platform. So what you see on your left are different data types that are required for the algorithm. Some examples being demand forecast, purchase orders, material movement, inventory snapshots, lead times with suppliers, etc. And in the middle, you have the C3 platform where the machine learning algorithm and the optimization algorithms runs and generates these recommendations. And these recommendations are surfaced through the inventory optimization application. Now, besides the application, the user interface for the end user, the data scientists can interact with the data on the platform through the Jupyter IPython notebooks. And also, the business analysts can develop models using the visual tool called C3 Ex Machina, and yet at the same time review business intelligence reports coming out of C3 Intelligence. So now let me share with you some examples or some results which are more at a granular, at a part level, so that you can see where the value comes from. So this is a view of one specific part at a factory. The blue line indicates the inventory levels on a daily basis, historically over a 3-year period. Okay? Now compare that with the green lines, very small, tiny green lines there, which represents the average consumption or the actual demand of the part. Right? So just this view by itself tells you that there's an enormous opportunity to optimize inventory for this part. Since your daily demand is so little and you are maintaining so high inventory levels. Right? And the red lines are arrivals of that material from the customer. So this view by itself was an aha moment for the customer, because using their current tools, there was no way for them to get a view like this. Okay? So the way this works on the C3 platform is we optimize inventory on a daily basis using the most recent data available. So using the different data types that I mentioned earlier, demand forecast, purchase orders, inventory snapshots, material movement, using all of those, the machine learning algorithm computes an optimal safety stock, which in turn drives optimal inventory levels. So in here, as an example, based on all that information, the safety stock that the optimization algorithm came up with is 120. Now, as new data gets in, the algorithm runs again, and if there's a need, it updates the optimal safety stock value. In this case, for this part, the optimal safety stock came down to 90, right? So this is a very dynamic way of optimizing your inventory, as against doing it basically once a quarter or at best once a month, which is typically what customers do today. Okay? So now, here are some results of the optimization per se. What you see here is on the top graph, the green line represents the actual daily inventory levels over that 3-year time period. And the bottom graph shows the comparison between the green and the blue line, which represents the optimal inventory level coming out of the C3 inventory optimization algorithm. Right? And the difference between the green and the blue represents the inventory savings opportunity. Right? So that savings opportunity that I referred to earlier, number 28%, that is an aggregate of this difference between the green and the blue lines across all parts that were in scope. Okay? And now, if you plot the distribution of the average consumption or the actual demand of the part versus the actual inventory, the distributions prior to optimization, which is the top part of the graph, they are very spread out, right? Which is not desirable. But after optimization, the distributions are so much closer. So the inventory level has come down much closer to the rate at which consumption happens. This is a view of the user interface. I encourage all of you to stop by our booth and actually get a demo of the application. Now here, so going back to the point that Binay made earlier, we basically tested a complex algorithm like C3 inventory optimization, right? Working, optimizing several parts across multiple locations with both the old instances, like the M4 here in this example, and compare that with the latest Skylake-based M5 instances, and saw improvement both in terms of performance, and the number is 21% here, as well as in terms of reduction of TCOs, which is 42%. And a similar exercise on the R5 instances showed performance improvement of 50% and TCO reduction by 49%. So the key point here is, as customers scale up on these latest generation of machines based on Skylake processors, they're going to see more and more benefits coming out of an application which is running on the stack based on Skylake processors. Okay, so that is the end of the presentation, and for my part, I encourage all of you to visit the C3 booth. And also there's a session tomorrow where we're going to talk about how customers can build AI applications in 1/10 the time and the cost. So that's tomorrow at 12:15. And with that, I turn it over to Binay.
Thank you, Dib. I think you can join me on stage. We're getting into the Q&A. So, hopefully you learned out of this, and hopefully you enjoyed this presentation. But what we really wanted to show is how C3 and Intel working together can really get you a benefit on some of the workloads and use cases that you might see. We have a number of sessions as well during the course of the week. We have one this afternoon, tomorrow, as well as on Wednesday. And then, in addition to that, please join us in the booth. Please visit the Intel booth. And we have some exciting announcements coming up at Monday Night Live and at the Andy Jassy keynote on Wednesday. So please stay tuned for that. So we're done with the presentation. I guess 10 minutes early, around 10 minutes early, which allows us time for Q&A. So if you have any questions, please look for folks like Billy and Danny to step up to the mic. Sure. Yeah. Go ahead.
Question, I think it's pretty good use case you had, right? So just how big was the C3 team and how big was the Intel team? Was it a joint combination on analytical team? What was the team organization structure?
Okay. You want to talk about C3 first? Yeah.
Sure. Right. So as part of that specific project that I talked about, it was 3 to 4 people from C3, and we interacted very closely with the customer resources. Right. So that was the nature of the engagement. But I turn over to Binay to add.
Yeah. So the way we worked, there were 2 parts for Intel's engagement. One was the Intel team working with AWS to make sure that all the optimizations. If you remember the slide I showed that had all the different tools, we worked closely with AWS to make sure all those optimized tools were incorporated as part of the C5 instance. So that was one part of the effort. The second part of the effort was working with C3 on the specific workloads and the services that they were using on AWS and make sure those were taking advantage of all the optimizations we've done. So that's roughly how we worked through this type of scenario. Does that make sense? So there's a general part as well as a specific part.
No, I'm getting. And then the course of that period, you said, so one question, like you mentioned very quickly, right? You are going into unknown territory. There are a lot of data ingestion, right? And data is spread on all over the places, right? Especially when you go to the manufacturing. So how did you get, in your program charter, you said you did the work in 4 weeks to get the information on the data?
Yes. Yeah.
So how do you get, like, for example, my problem is if I come, there are different manufacturing facilities, right? And key question here is, from one manufacturing facility to the other, right? Yes, we want it to be converging, but how do you go about to get the information on the data, right? How do you have fixed templates to figure out that how fast you can do the ingestion?
Sure. So there are two parts to it. Let me address the template piece of it. Yes, we do have what we call canonicals, which specifies what data types and individual fields or attributes are required that feeds into the optimization algorithm, right? So that is pretty much set for the most part. Then we work with the customer to help them understand this canonical template. And generally, it's the IT team at the customer who would figure out where to pull data from. But so this can be extracted on a one-off basis, or we can also use connectors. For example, if the data is in SAP, use SAP connectors to get that data onto the C3 platform. So there are different options that are available to achieve that.
All right.
Does that help?
No, that's good overview. I think I may get connected offline with you. Thank you for
Sure.
the information. Thank you, Vinay.
Thank you for the question.
Hey, could you quantify kind of the size of the data that you were ingesting? And I'm assuming it was streaming versus batch-oriented?
In this example, this was batch data, right? So the customer was providing data on those different data types like demand forecast, purchase orders, inventory snapshots, material movement, right? Typically once a day, right? But the platform also has the ability to handle more real-time data. But in this particular use case, this was.
You were getting your data about once a day. Could you talk a little bit about how much data you were actually ingesting?
So in this particular use case, as we are going through multiple factories, right? So one way to think about it is the scale of it is going to grow as more factories come on board. But in here, we are talking about so far somewhere between 50 plus GB every day.
Okay, and can you talk a little bit about some of the AWS technologies you used in the data pipeline that you were using?
So the C3 platform sits on top of the AWS stack. And so basically I don't have a slide out here, but it uses multiple AWS services. I don't have the specifics. I can connect with you later on.
Yeah, I think there was certainly services like the relationship database, and there were a number of others.
Yes, like Postgres, Cassandra, those would be the two databases that we use.
If I remember right, in total you used around 20 services. Yeah. I saw the list somewhere. Yeah. Thank you. Any other questions?
Yeah,
Go ahead.
My name is Steve. Quick question for you. In terms of, you said that you were getting performances from C3 to C5, about a 50% increase in performance. Can you tell us about the tools? Did you use tools to help optimize those workloads to migrate from C3 to C5 to get a 50% increase, or was it just a natural increase based on scaling up?
Okay. So a lot of this is really something you don't have to worry too much about as long as you use the deep learning AMI, Amazon Machine Instance. If you use that on C5, the optimizations are in there, and it'll be continuously updated as we continue to optimize. So as long as you use the deep learning AMI on C5, you should get all these optimizations in there.
Okay, good. Well, thank you.
Okay, you're welcome. Okay, no more questions? Well, thank you very much for your time and enjoy the rest of reInvent.
Thank you.